Hey guys, I've been wanting to make this video for probably 12 years. About 12 years ago I upgraded my table saw with a variable frequency drive. Actually probably over 12 years ago. 12 years ago would have been the version that I'm going to show you today. But and I did this kind of as an experiment and proof of concept, and there's a bunch of things I wanted to test and trial, and you know, the tool I was using all the time day to day was my table saw, so I figured that would be a great place to start. I entitled this video, you know, world's best table saw upgrade. And there's a reason for that, and a bunch of reasons for that, and I'll show you guys there today. I imagine down the road in the future you'll be seeing table saw manufacturers start to put VFDs on their table saws, but it's not something that that's going to happen quickly. We see VFDs already on bandsaws. Lathes have had them. Wood turning lathes, I guess, would have been the first tools that the VFDs were installed on. So I've done all kinds of upgrades over the years to various friends, and like my father's has a one-way lathe. It's a Cadillac of all lathes, let's say, and he has a VFD on it. So I modified his VFD so he can run his bandsaw from the same VFD. So so there's a bunch of reasons, and what I want to do is just highlight the reasons, you know, benefits of using the VFD on your table saw. So the first one is time saving, and I'll show you guys some demonstrations here in a sec. But if you can imagine, if you're always you're doing a project and you get some ripping, and then you're switching to cross cutting, and or you're doing a piece of furniture, right? And so you want to have your 80-tooth blade in there for your nice fine cuts, so you reduce the amount of sanding that you're doing. But what's happening is, if your next cut you need to rip something to avoid having burnout and whatnot, you're probably going to end up switching your blades. And I do that with one blade. Okay, so I have typically a 50-tooth blade on my table saw, which I'll show you in a sec, and I just adjust the speed up and down. And so what I do is I rip at half the speed that the table saw normally runs at, and I do my cross cutting at one and a half times the speed that the table saw normally runs at. So if the table saw is running at, say, 3,500 RPM, just an average. Like, each table saw manufacturer has a slightly different speed, but just as an average, it's around 3,500 RPM. So I'll rip at around 1,800 RPM on my table saw, and there's a very good reason for that. I'll explain in a sec. But and then so that'll give me with a 50 tooth the equivalent of a 25 tooth, let's say 25 tooth, and then when I'll do my cross cutting, I'll go 1.5 times the speed, so then I get about 75 tooth with the same blade, just equivalent number of cuts. Yeah, there is some differences in the blade design, but I found that it's with a 50 tooth blade you can do probably, I very seldom change my blade. And so yeah, so that being the first benefit is the time saving for the blade changes. Blade stoppage. The VFD is able to slow down the blade so it stops almost instantaneously, and I'll show you guys a demo of that. Alright, so what I've done is I've disconnected the belt off my table saw here. And I want to just talk a little bit about the motor that I have here. I don't know if you guys can see clearly here, but you probably can. Yeah, there's no fan on the back of this motor, and so I have this handy dandy start-stop station, which has magnets on the back. Okay, so when I designed this this VFD setup 12 years ago. What I was doing at the time is I had a small business where I was selling these upgrades, and so what you're going to see is basically my demo. I've since pretty much sold all the ones I did have built, but I have a couple left over. But this is the demo, so it's the wiring in it isn't the best, but you know, it's not my tidiest wiring, let's just say. But what the magnets allow is that I can basically stick the start-stop station anywhere on the table saw. So as you're working, you're doing fine cut. You know, sometimes you'll find that you get a sheet of plywood on there or something. Your start-stop station is not always accessible. So with this, you can put it on the top of the sheet of plywood. So it improves your safety. You've always got your start-stop station somewhere close. And I want to show you guys here just how quiet this motor is. So right now it's running at 60 Hertz, which is 1800 RPM. So one of the things I did here is I installed it, instead of a 3600 RPM, which is what's on typical table saws, I've put a 1800 RPM on this table saw. And what it does is, by having an 1800 RPM motor, I get double the torque at 1800 RPM than I would with a 3600 RPM motor at 3600 RPM. And by doubling the torque and putting a 52 blade on at half the speed that normal saw would run at, you basically have double the torque on each tooth as you're cutting. So at 1800 RPM, a 50 tooth blade surprisingly cuts amazingly well. Okay, the speed adjustment. So this is 3600 RPM, and you can hear my voice perfectly, right? I don't know if you guys can see this turning. It is turning, and this allows me to then overspeed the saw. So you know, your blades are usually good for 7000 RPM. I haven't found any necessity to go up that high, but I can. But I have this program right now for it's 200 Hertz is the fastest speed. So 200 Hertz is about 56,000 RPM, thereabouts. And I can vary the speed, take it down to, and you can see barely, this thing's barely turning. And you can try to stop this, but it's incredible the amount of power this thing has. And then one really big benefit, I mentioned the ability to save time with this table saw. So besides the blade changes, is the stopping. So you can see I got this going at 1800 RPM. This is 1800 exactly, and then when I hit stop, you're looking at less than a second to stop your saw, your motor. It takes a little bit longer with the blade because of the inertia, but you'll see it is pretty quick. If I go to the full 200 Hertz, then it's still stopping pretty quick, a couple seconds. So I'll show you guys this, the equivalent of this without the VFD running, and I'll basically turn off the VFD in a sec. So here's the same test, but with me turning off the VFD. So I got a switch here on the VFD. I'm going to turn off, and right now, and waiting. Still going. Yeah. Still still going. And there it goes. So you can see there's a substantial difference between the VFD doing what's called dynamic braking, and there's even a number of things you can do to make the VFD even better. You can add braking resistors, or you can, which is the standard thing, or what I'll be showing in the future video is I'm actually working on a dynamic braking but with batteries. So that's something I've been wanting to do for a while, and it's not, the application isn't for the VFD, it's for a future project, but I just thought it would be kind of neat to test it with the VFD. Alright, so one of the other cool things that I did with this VFD is I've got, as I mentioned earlier, I've got two outputs on the VFD, so I can connect two different motors to the same VFD, and inside I got a special program and wiring setup, and there's a control relay in there, and but what I'm able to do is I'm able to use one VFD and I can run two different motors, so I could have two tools. So this could be my table saw setup, and then I could have a lathe, so I could have the variable speed control on my, I forgot to turn that back on, so I had my I could have my variable speed control on my, let's say, my lathe, and then I could have my table saw could be on this speed control over here, which I tend to use like 3 speeds, right? So when I'm doing ripping, I'm going at 1800 RPM or so. When I'm doing, let's say, I want to get a decent cut, I'll go around 3600 RPM, and when I want to get a really nice fine cut, I'll dial this up to full speed, around 6000 RPM, and I'll get a really nice fine cut. And I'll do an example showing you guys different cuts and how the wood looks at different speed. But so, you know, I can run this motor, stop that motor, and then run this motor. And you could hear the difference. So this is the motor, one motor running at this is my table saw motor running at 60 Hertz, and it doesn't have a fan. So the other motor is a typical motor with a fan, and it's going to run it also at 60 Hertz. So you can see the difference in the sound with this one. And of course I can change the speed on this one. And I can even use the potentiometer. So that was this motor running at about 10,000 RPM that you heard the crazy noise. I don't recommend that, by the way. I mean, just running it with no load doesn't hurt it, but I'll do that again just in case you thought that was cool, because I do. Very loud. I just want to show again the difference in sound. I'll stop this guy. See? Quick stop as well. Start this guy. Same frequency. Can you hear me now? So I think that was an effective demonstration on the sound. Now once I hook table saw up, of course, the blade does make quite a bit of sound and noise. So okay, so now I'm just going to zoom in here and show you guys a a close-up of this thing. So my company was VS Techniques, and I was doing this. So this is, as you can see, I call it VS Shopmaster 1012. So it's 100 volt to 120 volt AC input. Got fuse in there. Then output voltage is 0 to 230 volts, 3-phase, pulse width modulated. And the output rating is 5 amps continuous, and then 7.5 amps for 1 minute. Now to do that, you need like 20 or 25 amp circuit feeding this thing, which I don't have. I was forgetting about that little detail when I wired up my shop here. And I've only wired this up for 15 amp circuit. So inside I've got, you know, some electrical parts for those of you who aren't electrical savvy. Those who do understand a little bit more, I've got basically a relay here, and that's what does the switching between my two outputs here. This is the VFD. It's a little Reliance MD65 AC drive. You could probably pick this up on eBay for pretty cheap. They are a classic or an obsolete version. I don't think they sell them anymore or build them anymore. But it is one of the best little AC drives I've ever used. I've used many over the years, but this is a nice solid little drive. Has a lot of features, and it, as you can see, it allows me to do some really good braking with a dynamic braking resistor. So that's what, you know, the panel looks like. And then, as I said, this was my demo, so my wiring quality got better over the years. So this was really the first panel I ever built, and I tested this whole dual tool control concept with. So future, or the other panels I've actually sold were much neater wiring than this. This down here, you can see I've got 5 cables coming in. So one of them is my ACN, which is just this this plug here. I got a nice right angle connector. So all my cables are heavy duty. I use basically SOW cables, 12 conductor number, 4 conductor number 12 gauge here, and I use these heavy duty twist lock plugs. This is my M1, which is the table saw, and then M2 is this second motor I had here, just as a demonstration. And the cables coming out here are for the 2 selector switches I had here. I was showing you guys on the back of the motor. This is basically M2, which kind of goes with this motor. And then this one is M1. Now that's another neat feature of this. As you can see, it could be on one tool and go over to your other tool and stop that motor with the other start stopper. So either start stop station stops the motor. And I have this 4th switch here, and you're probably wondering what it's all about. Some applications, like lathe, you do need a reverse. You don't on the table saw, but I found it's a neat little way to clean your blade. Just run the saw backwards and run a piece of wood across the blade backwards, and it scrapes this crap that's on the saw. So I'll just show you guys how quickly So this is me going backwards, forward, backwards. So you would never be able to do that without a VFD. You would be damaging your motor. But so that's another neat little feature of this. Right, so now just want to talk about a few other features of this saw. So, you know, in order to be the world's best table saw upgrade, there's a few. See, it fell and just kind of stuck there. There's a few other features of this this upgrade. It's not just the VFD. A big part of it is this motor here, and this motor is. I'm gonna try it. It's fairly heavy. Gonna try to show you guys the nameplate here. So I'll take a snapshot of that later. There's a very important detail here, and it's this one, design A. Okay, it is only a 1 horsepower motor at 60 hertz. Still 1 horsepower at 120 hertz. Okay, and of course I can feed this motor from 230 or 480, 460. So what's special about this design A that I just showed you guys? Well, design A motor, and I'll put the graph up here in the video. Is basically an inverter duty design, and what it allows this motor to do is to, as long as it has the right amount of current coming into it, it can supply up to 500% of its nominal torque. It's got a lot. It's almost equivalent of a 5 horsepower motor for a short period of time. So it's got the, it's got the package of a 1 horsepower, but it can peak to 5 horsepower, which no other let's say single phase motor can do. You'd have them made by Marathon. It's called a Black Max series. In case you're wondering, you'd like to get a great motor for your table saw, this would be it. So my table saw is just a regular, very standard. It's a rigid table saw. TS 3650. I don't think Rigid sells this model anymore. This was a common model 12 years ago, and it's got the Herculift pedal, basically push pedal. Saw drops, and when you push the pedal, you can roll your saw around anywhere in the shop. It's got a really good fence, and I have upgraded with this Incra miter gauge here. Okay, so I think the first test I'll show you guys is the smoothness of the edge test. So I'm just gonna cut this off. I'm gonna go slow first, so you guys can see the ripping. This is when you cut it slow. Tear out, I guess. So here we go. That's at 60 hertz. If you can see the VFD. And you can see all this fraying here is happening. Right. So, and the cut is fairly rough. Now I'm going to speed up the saw, and it's going to get noisier, but it's basically the wind caused by the blade that's making all this extra noise here. So I'm going to go full speed. So you can see much smoother cut here. Okay, And actually, there is still a little bit of tear out, but you know, you can basically just wipe it off with your finger. Now I'm going to do a rip cut here. So that's 3 inches and an eighth, and I'm going to be ripping down at around 60 hertz. See, it just fairly easily went through that, and you know, there's no burnout. Fairly smooth cut here. Okay, even though this is a 50-tooth blade, and you know, this blade is as old as my VFD. It's probably 12 years old. I haven't bought another blade since, and I haven't sharpened it. So, you know, obviously I could do better with a new blade, but it still works. So I changed it. So it's 3 1/8, and my saw can do almost 3.5 inches of ripping. So it'll allow you guys to see the top of the blade here. So here we go. I'm going to try to push it through as fast as I can. Now, I did hear some, it did slow down a little bit. I was really pushing, but normally you would allow the saw to rip. You know, I was pushing it as much as I could. I did get a little bit of burnout here, but we're talking about 3 inches, and it was a little hard because I didn't have quite enough space here to allow my push block to be on the outside of the fence. So as you can see, I was kind of going sideways with my push block, but it got through that fairly easily. The blade stoppage, you know, as I talked earlier, the amount of time I saved. So I just want to show you guys what that looks like when I just turn off the VFD. Okay, so I'm gonna speed it up to what. So this is about the speed of a normal motor, and you can watch the time here at the bottom of the video when I hit this button. How many seconds it took to stop versus what a normal table saw would take when you hit your stop, and then the blade is just freewheeling. Finally. So it's quite a bit of difference in you know, if you're doing a lot of cuts and throughout your day, it does add up to quite a bit of time, right? So, and then of course over the 12 years, the amount of time I've saved just with the saw stopping faster, it's been a good benefit. All right, so now I'm going to take another piece of ash. This is actually just a rough piece of lumber here. Just basically firewood I cut in half, and let's do another cut so you guys can see. And then I'll do a cut at 3600 RPM so you guys can see the difference between cutting power at 18 versus 36. So that was the full width, full height of the blades. You can see the blade come through, and there was a knot here as well. So that's a pretty good test. I mean, maple's a little harder, but I don't find that maple's any harder to cut than this ash here. So so now I'll show you guys what happens at a higher speed. So you probably see some burnout and other things here. So here we go. This would be the speed of a normal maple saw. You're bogging down. What the VFD does is it slows down, and you can actually bog down the blade and it'll start back up, but it's not instantaneous and destructive like a regular table saw where pieces fly everywhere. It's nice and smooth, back this out. I assure you, you can't smell what I smell, but I'm going to see some burnout on this. So, you can see some burnout here, which I wasn't seeing at 1800 RPM at all. And over here, lots of burnout. As soon as I hit that knot in the wood, I'm noticing is the difference between the smoothness of a cut here. You could see a little bit of fraying here now at 1800 RPM, and then on the other side, of course, it's a much smoother cut. And this is where I was bogging down. You see the saw line, but I didn't have that issue at 1800 RPM. Alright, so I just want to summarize a little bit here of what I've just showed you guys. The VFD allows me to use a 50 tooth blade for 90% of my cuts, as I said. I do change my blade for mainly when I'm cutting non-ferrous metals. I do a lot of projects in aluminum, and I basically do all my cuts on my table saw. I get basically the ability to be able to get exactly the right type of cut without changing my blade every time. So that's a nice feature. And the faster blade stoppage, of course, makes a huge difference. Every time I stop that blade, I'm saving 10 seconds. As I mentioned earlier, the big power benefit is the fact that I can run an 1800 RPM motor on this saw. So the saw actually came with a 1.5 horsepower motor, but this 1 horsepower motor, as I mentioned earlier, if I've got the VFD power feeding into it, I can get about 5 horsepower of equivalent horsepower out of this motor. So at that point, what happens is the belt slip, because I don't have enough wide enough of a sheave and enough friction area there to maintain to transfer the torque to the belt. So that is really the limiting factor with this rigid table saw. but in the future I do have a 15 horsepower VFD that I'll do a test on. It's over here in a box, and what I'll do is I'll put a 24 tooth blade on there, and then I'll run this at a 3600 RPM. I'll do different tests at different speeds in that video, and then just show you guys the power if I have no limit of, let's say, infinite power into this motor, what kind of cuts and speeds of cut can I expect. So I'll do that in the future video. Obviously you've heard the noise difference between this type of motor and a motor with a fan on the back. It's much more quiet with this totally enclosed non-ventilated marathon motor. The burnout problem, virtually goes away with this setup. And the stall protection. So you've seen when I was pushing that piece of firewood there through the blade, and then the blade was actually slowing down. That was not the belt slipping. That was actually the VFD doing what's called a stall protection. So it was just basically allowing the motor to stall without tripping it out, kind of thing. Have that motor slow down to almost 0 RPM, just back off the wood, and it'll restart without tripping up my breaker. So the breaker will typically trip if I'm doing a lot of cuts, continuously pushing this everything all the way to the max. And after a little while, the thermomagnetic, the thermal circuit in the breaker is probably what trips it out. It is possible to adjust the VFD to only output a certain amount of current, so I never ever trip the breaker. But I'm offsetting extra power for an occasional trip of the breaker. One neat feature, and the main reason why I got into using buying this VFD and testing this idea out in the first place, was in a previous property and home, my shed was fairly far away from my house, and to get electricity out to the shed would have forced me to cross right through my house, basically go through some cement or brick wall, dig a trench, probably 150 feet to my shed, and then run underground wiring over to the shed. Now I had planned to do that eventually, but I was always opting to just run an extension cord over the grass and power my tools that way, because the day or 2 days it would take me to run this electricity, I could accomplish a lot in those 2 days. So VFDs is my specialty in my profession, and I knew about them since 1996, and so I figured why don't I just get a VFD, and then I can use the VFD to compensate for the voltage drop in the extension cord. So I did that test, and the first VFD I built was really crude. It was actually a little red metal toolbox, and I stuck the VFD inside with a fuse, and basically I would plug it in, and I had bought this same motor that's on this table saw here now, and it worked, so in the end I eventually thought of how could you sell these things with such a great benefit for the table saw, and I was like, well, if I could power more than one tool with it, that would make it more marketable. So that's where the idea came, to power multiple tools from one VFD. So then you just buy a separate motor for each piece of equipment, and I've sold a few back in the day. I stopped selling them when I started my own company as an engineering firm. So then my lawyers basically told me, you know, you got to stop doing that because you're selling stuff and you have your own corporation. People could just sue you for the fun of it, and so I stopped selling these things at that time. It's either that or pay for insurance, which was very costly. And I wasn't, you know, I wasn't selling enough of them to offset the cost of the insurance. Anyways, so I hope you enjoy the table saw demonstration. As I said, I'll be doing some future videos here with the table saw. I've also made several inventions in my career, and I'll eventually make a video, just a mismatch of various inventions that I've done. Just hopefully it will be entertaining. Obviously I can't show the inventions that are trademarked or that I've built for other people, but I'll talk about them a little bit in that video. Bye for now.